Hi, good evening, everyone. This is Shefali Singla, and in this session, we are going to talk about some applications of divide and conquer. कल वाली सेशन में हम लोगों ने डिवाइड एंड कॉन्कर पे डिस्कशन स्टार्ट की थी. वी लर्न दैट हाउ डिवाइड एंड कॉन्कर वर्क्स एंड किस तरीके से रिकर्सिव कॉल होती है, और जहाँ पे भी हमारे पास रिकर्सिव कॉल आएगी वी can write the recurrence relation, and ultimately by solving that recurrence relation we'll be able to return the time complexity, right? So same concept will be following in today's session. So next 2-3 applications discuss करेंगे. First of all we'll talk about merge sort. Merge sort के basis पे आपको काफी questions मिल जाएंगे. Merge sort is one of the sorting technique which uses the concept of divide and conquer. That means we will be dividing the elements which we have to sort. जो elements आपको sort करने हैं पहले हम उनको divide करेंगे into the small parts, because if you are directly going to sort the large number of elements, it is going to take more time. Just consider if we have to sort 5 elements, आपको 5 ही elements given है, तो time लगेगा like some fraction of seconds. And if you have to sort 100 elements, it might be taking 1 minute. If we have to sort 1000 elements, it might be taking 5 minutes or so. तो जैसे जैसे प्रॉब्लम का साइज बढ़ता जाएगा, जैसे जैसे नंबर ऑफ एलिमेंट्स बढ़ते जाएंगे, hence it will increase the number, hence it will increase the time. करेक्ट? सो आइडिया इज टू डिवाइड द प्रॉब्लम, क्योंकि अगर एक ही एलिमेंट होगा या दो ही एलिमेंट्स होंगे, इजीली वी कैन रिटर्न देम इन द सॉर्टेड ऑर्डर. एक ही एलिमेंट है तो डेफिनेटली असेंडिंग ऑर्डर भी वही है, डिसेंडिंग ऑर्डर भी वही है, स्मॉलेस्ट एलिमेंट भी वही है और ग्रेटेस्ट एलिमेंट भी वही है, right? So let's start with the merge sort. So merge sort is one of the sorting technique which is an application of divide and conquer, and it uses the concept of recursion. So if a problem is large, we'll be dividing this into the small problem. Sorting की हम कुछ application कुछ properties करेंगे, but not in today's session. आज सिर्फ और सिर्फ concept understand करते हैं. When we'll be starting with the remaining sorting techniques, that time I'll discuss that what is in place sorting technique, what is adaptive sorting technique, like that. Okay, all right. So let's consider some example is, let's say we have the elements like 10, 20, 30, 40, 11, 21, 31 and 41. These are the elements of an array. ये एक array में आपको elements given है और इस array को हमें sort करना है. That means expected output will be 10, 11, 20, 21, 30, 31, 40 and 41. So here we have the index positions of an array. Let's assume that this is 1, 2, 3, 4, 5, 6, 7 and 8. Okay. Now what we'll be doing is, since the problem is large, since more than one element is present in the array, so we'll say that this is a large problem. So what we'll be doing is, we have to sort the elements starting from the index 1 to 8. Okay, so we have to sort the elements from the index 1 to 8. But since the problem is large, so what I'll be doing is, I'll be dividing these elements into two equal parts based on the position mid. So 1 plus 8 is 9, 9 divided by 2 is 4.5. So I'm taking 4 as the middle element. So on one side, I'm taking first half of the element. So its index is 1 to 4. And on the other side, I'm taking the remaining 4 elements starting from the index 5 to 8. Okay. Now, again, the problem is large. So again, we'll divide it into the sub-problems. So half of the elements 1 to 2 will be in one part of the problem. 3 to 4 will be in the another part of the problem. Similarly, here we'll be having 5 to 6 in one part of the problem. 5 to 6, 7 to 8 will be in the another part of the problem. Again, we are not having one element. So we are assuming that if we have only one element, if n is equal to 1, if there is only one element, then return एक ही element है तो उसका ऑर्डर क्या होगा, इट विल बी रिटर्न द एलिमेंट इटसेल्फ, जो भी इंडेक्स पोजीशन पे एलिमेंट है, जस्ट रिटर्न इट. नाउ again I'm going to divide this. So here will be having only one element, that is the termination condition. I is equal to j. I'm considering I as the starting index and j as the last index. So 1 to 1, 2 to 2, 3 to 3. Then we have 4 to 4, 5 to 5, 6 to 6, 7 to 7, and 8 to 8. This is 5 to 5, 6 to 6, 7 to 7, 8 to 8. So when I is equal to j, if starting index is equal to ending index, this means that there is only one element. So basically it is forming this condition. It is representing that there is only one element. अगर एक ही element है, then what we are doing is we are returning a of I. A of I means जो भी element available है, just return that element. आप a of j भी लिख सकते हो, because anyhow in this case both are equal. Now, since we have reached to the termination condition aate, it will start returning the values. At the index 1, we have 10. At the index 2, we have 20. At the index 3, we have 30. At the index 4, we have 40, 50, 60, 70, and 80. Individual element is sorted. Now after that, after getting the solution of the sub problems, third step in the divide and conquer is to merge the solutions. So this list is sorted, second list is also sorted. Now we'll merge it, we'll combine it. So we'll compare these two elements. 10 is smaller than 20. Similarly, we'll merge these two solutions. It is 30, 40. Now, arrange these elements, merge the solution of the sub-problems to get the solution of the main problem. Now, solution for the first sub-problem is available, solution for the second sub-problem is available, so we can merge it to get the first four elements in the sorted order. 10 will be compared. This is the important point. If you observe here, by this time, first list is sorted, second list is sorted. अब जो comparison होगा, it will be done with the elements of the other list. Within the list, comparison won't take place. क्योंकि already ये list sort हो चुकी है, तो comparison दोबारा से नहीं करेंगे. 10 will be compared with 30. What I'm doing is I'm comparing 10 with 30. दोनों list का first element लिया, and we are getting here smaller element as 10. Then next comparison में, since 10 is belonging to list 1, so I'll be taking the next element of list 1, that is 20. Now 20 will be compared with 30. So here we are getting the output as 20. Now we have to take the next element. Next element is not available. So this means that first list खाली हो चुकी है. Second list के elements available हैं. सिर्फ second list के elements available है, तो इसके बाद कोई comparison नहीं होगा. Second list को as it is copy करवा दो. Second list में comparison क्यों नहीं कर रहे? I'm repeating this point. So why are we not comparing the elements of the second list? This is because these elements within a list are already sorted. Okay. Similarly, we'll go here. I'm so sorry. Why did I took 50, 60, and 70? Elements were, I'm so sorry guys. Elements were 11, 21, and 31. जो elements है वही लेने, even you guys are not pointing out. Okay, so at the index 5, we had the element 11. At the index 6, we had the element 21, 31, and 41. So after merging these two, we'll be getting 11 and 21. After merging these two, we'll be getting 31 and 41. Now merge these two lists. 11 will be compared with 31. 11 will be compared with 31. Obviously, 11 is smaller, so we'll be including 11 in the result. Since 11 is belonging to list 1, focus on this thing, because I'll be discussing the best case and the worst case for merging. तो वहां पे number of comparisons में difference आएगा. Number of comparison का question directly भी आया हुआ है, और indirectly in the form of file optimal file merge pattern में भी आपसे number of comparison पे question पूछा गया था. Okay, so just focus in best case and worst case, what will be the number of comparisons. I'll be coming to that point. Now list 1 is completely over. दो elements थे, दोनों consider हो गए. So we need not to compare the remaining elements of list 2. So it comes out to be 11, 21, 31 and 41. Now we are available with the solutions of first list is sorted, second list is sorted. We have to merge these two lists. So we'll be doing the comparison. कैसे comparison करेंगे? 10 is compared with the first element of list 1 will be compared with the first element of list 2. That comes out to be 10. Since 10 is belonging to list 1, here we have got 10. Since 10 is belonging to list 1, so we'll be considering the next element of list 1. Now 20 will be compared with 11. And we know that 11 is smaller. So here we'll take 11. Next, 11 is belonging to list 2. Now we'll be taking next element of list 2, that is 21. 20 will be compared with 21 now. Smaller element is 20. So here we'll include 20. 20 is belonging to list 1, so we'll consider the next element of list 1, that is 30. 30 will be compared with 21. 21 is smaller element, so we'll be taking here 21. 21 belongs to list 2. जिस list को belong कर रहे हैं उसी list का next element लेने हैं. If it is not there, that means one list is over. We can directly copy the elements of the list 2. No comparison is required in that case. So here we'll get 30 and 31. 30 is smaller. Next element from list 1 is 40. 40 and 31 will be compared. It is coming out to be 31. 31 is belonging to list 2 will be taking the next element of list 2. This comes out to be 40. Now list 2 becomes empty. So no comparison is required because one list is already over. So we have got the elements in the sorted order 21. Then we got 30, 31, 40 and 41. Ultimately, this is how merge sort is going to work, and at the end, we are getting the sorted order. Make sense? So top down approach में हमने problem को divide किया है, and in the bottom up approach we are finding the solutions, we are returning the solutions of the sub problems, and ultimately we are returning the solution of the original problem. Make sense? अब यहाँ पे if you observe what we were doing is if there is only one element, then we have returned that element. So this is a termination condition. This is defining the termination condition. Else mid is equal to, अगर problem large है, if the problem is large, then mid is equal to I plus j divided by 2. This will be taking constant time because we are performing just a few arithmetic operations. After that, we are making a call on the first half of the problem, I से लेकर mid तक, and then mid plus 1 से लेकर j तक. If you observe here, there were 1 to 8. तो first part में हमारे पास elements कहाँ तक आए? 1 to 4. If this is the mid, that means, and this is I and this is j. That means in the first part we are taking the elements from I to mid. Next में mid is 4. If mid is coming out to be 4, तो हमने यहाँ पे क्या लिया? 1 से लेकर 4 तक. And second part में we were getting the elements from 5. That is mid plus 1 to 8, like this. Correct? And in this case, we have to work on both the parts of the problem. कल जो दो हमने applications की थी, part of an element and binary search, in both the problems, we were just focusing on, we were just getting the solution for one part of the problem. And on the basis of that, we were getting the solution for the overall problem. But if you observe here, जब sorting की बात होती है, this means that we cannot ignore any part of the problem. Sorting means कोई भी element को आप discard नहीं कर सकते हो, आपको ultimately सारे elements को return करने. So we are working on both the parts. In one part, how many elements are there? It's n by 2. If here total n elements are there, I to j means total n elements are there, and let me call this function as t. If n elements are there, in the first part, there will be half of the elements, that is n by 2. In the second part also, there will be n by 2 elements. After that, there is a merge function. Here we'll consider the merge function for best case and the worst case because we do not know as of now what is the time complexity. Now if you observe, I had taken two cases for the merge. Okay, so if we talk about the merge function, guys, I'll be coming to that slide. Okay, uh, that is Telegram group. तो आप जो भी मैं ये सब लिख रही हूँ जस्ट फोकस ऑन अंडरस्टैंडिंग द कॉन्सेप्ट क्योंकि आपको ये सब कुछ पीडीएफ में मिल जाएगा. So merge function. There are two cases for the same. One is the best case and another one is the worst case. Best case and worst case. Merge करवाने के लिए ये सिर्फ. So best case is saying that first of all we are taking the elements from the first list. Second list का कोई element नहीं आ रहा, so it will be returning less number of comparisons. For example, here we have the elements like 10, 20, 30, 40. This is list 2, 50, 60, 70, and 80. If you observe here, in total we have 8 elements. So number of elements in this case are 8. Let us find out that in order to merge these two lists, how many comparisons are required. So what we'll be doing is we are taking the first element from both the list. So 10 will be compared with 50, that is returning 10. Since it is belonging to list 1, so we'll be taking the next element of list 1, that comes out to be 20. Taking the next element of list 1, that is 30, 30 will be compared with 50. Taking the next element of list 1, it is returning 40. Now list 1 is over, so we do not need to perform any comparison. अब यहाँ पे हम कोई comparison perform नहीं करेंगे. So for 8 elements, how many comparisons are taking place? Best case means when we are picking up the next element from one list only. So in this case, how many comparisons are done? Number of comparisons in best case. अगर 8 elements है, first list में 4 elements है, second में 4 elements है, so there are 4 comparisons. If there will be 16 elements and in one part we have 8 elements and in the other part will be having 8 elements, तो हमेशा एक एक करके first list के या second list के सारे elements आगे and that will be over. So number of comparisons in the best case for merging the files or the list, it comes out to be n by 2. Make sense? Now similarly, we'll find out the number of comparisons for the worst case. In the worst case, I'm taking the example. Worst case में क्या होगा? एक element first list से आ रहा है, दूसरा element second list से आ रहा है, तो उसके according example consider कर लो. Let us assume that the list is 10, 20, 30, 40. Elements are sorted within the list. In the second list, I'm taking the elements 15, 25, 35 and 40. Within the list, these elements are also sorted. दोनों list sorted है. Now we want to merge this to get a single list. So what we'll be doing is we'll be considering the first element from both the list. So 10 will be compared with 15. 10 is smaller. So now since the element is picked from list 1, so we'll be considering the next element of list 1. This will be 20. 20 will be compared with 15. If you see here, 15 is smaller, but now 15 is belonging to list 2. So we'll be keeping the element 1 as it is and we'll be taking the next element from list 2, that is 25. Now this is returning 20. Since 20 is belonging to list 1, so I'll be taking the next element of list 1, that is 30. Are you getting what I'm doing? जिस भी list का element select हुआ है, उसी list का next element consider होगा. Next is 25. 25 is smaller since 25 is belonging to list 2. So we'll be taking the next element. 30 will be compared with 35. 30 is selected. Then next element from list 1 is 40. 40 will be compared with 35. Here 35 will be taken. Now 40 will be compared with 45. 40 is smaller. Element is over. So no comparison is required because it is already over. तो अगर यहाँ पे हमारे पास टोटल नंबर ऑफ एलिमेंट्स 8 थे, इस केस में क्या हुआ, एक एलिमेंट लिस्ट 1 से आ रहा है, देन लिस्ट 2, लिस्ट 1, लिस्ट 2, लिस्ट 1, लिस्ट 2 alternatively. So this is behaving as the worst case, because in this case number of comparisons required are more as compared to the best case. बेस्ट केस में एक ही साइड से आ रहे थे, सेकेंड लिस्ट को कंपेयर करने की जरूरत ही नहीं थी. सो इफ n एलिमेंट्स आर देयर, तो एंड पे क्या होगा, सिर्फ एक ही एलिमेंट बचेगा और उसके लिए कंपैरिजन की जरूरत नहीं है. अदरवाइज इन ऑर्डर टू सेलेक्ट ईच एलिमेंट वन कंपैरिजन इज रिक्वायर्ड. सो in the worst case number of comparisons, very important point, number of comparisons required are n minus 1. मेक सेंस. -1 क्यों कर रहे हैं, क्योंकि एंड पे आपके पास एक ही एलिमेंट बचेगा और उसके लिए कंपैरिजन की जरूरत नहीं है. मेक सेंस. बट जब हम टाइम कॉम्प्लेक्सिटी फाइंड करते हैं, एडिशनल टाइम रिक्वायर्ड फॉर मर्जिंग और फॉर रिटर्निंग द सॉल्यूशन, n/2 मींस इट्स ऑर्डर ऑफ n, right? 1/2 of n, 1/2 can be ignored, and n-1 is order of n. This means that for merge function is taking linear time complexity in both the cases, best case and worst case. But if they are asking for the exact number of comparisons, then you cannot say it's taking the same number of comparisons in the best case and the worst case. Okay? So let's go here. Now, since we have observed that the merge function is taking, merge function के लिए कितना time चाहिए merge करने के लिए? Here nothing is mentioned. Best case में it requires n time, and in the worst case also it requires n time. So we can write here the recurrence relation. Anyhow कोई फर्क नहीं आ रहा best case है या worst case है, it is going to take the same time complexities for each step. Returning case, so this will be taking linear time complexity. So ultimately, if we try to write the recurrence relation, this comes out to be T of n is equal to, ये तो constant time ले रहा है because this is a termination condition. Here we are getting, it takes constant time if I is equal to j, if there is only one element, then I is equal to j, or directly you can say it's, okay, what is happening? I'm so sorry. Okay, if otherwise, if I is not equal to j, that means the problem is large. So first of all, you are dividing the problem, that is taking constant time. After that, you are making a recursive call on the left side. One part of the problem, that is taking n/2. Second part is also making a call to the function n/2. Additional time required for merging or for returning the solution, that means we are returning the value of f of n, that is n. Now simplify this. So we'll get the recurrence relation as Tn/2 plus Tn/2 comes out to be 2Tn/2. And for additional function, this is n. Best case may be n hai, worst case may be n hai. So this is the recurrence relation for best case as well as worst case. क्योंकि किसी भी टर्म में कोई चेंज नहीं आ रहा है बेस्ट केस एंड वर्स्ट केस, that means merge sort will be returning the same time complexity. This is not adaptive because in whether the elements are sorted or unsorted, merge sort अपना ही time लेगा. It is not going to take less time or more time if the elements are sorted or not sorted. So basically adaptive is when it's a pre-sortedness of the elements. If pre-sortedness of the elements is taken into the consideration, यानी कि elements पहले से ही sorted है अगर हम उसको consider कर रहे हैं, then the algorithm is adaptive. But here it is not considering, or in the best case and the worst case we are having the same time complexity, so merge sort is not adaptive. Anyhow, I'll be talking about these terms in tomorrow's session. What is adaptive, what is pre-sortedness, what is in place, stable, and so on. So can somebody tell me that if this is the recurrence relation, so what will be the time complexity? Now you very well know that how to solve the recurrence relation. Moreover, on this case, you can apply the basic master's theorem, right? F of n में कोई logarithmic term नहीं है, a is greater than equal to 1, b is strictly greater than 1. So this is straight away the case from the basic master's theorem. Quickly return the time complexity. It will be n log n. So let me write this as theta of n log n, because in worst case it's taking n log n. In best case also it is taking n log n. So we can represent this as theta of n log n. Make sense? Or you can call this as worst case पूछा है तो n log n, best case पूछा है तो it is n log n. So this is about the reconciliation and time complexity for merge sort and the working of merge sort, and here is the algorithm. From the algorithm we have written the reconciliation, and on the basis of that we are returning the time complexity. Anyone having any doubt on this one? Need not to worry about noting down all the things. आप मुझे रिप्लाई दे सकते हो, क्योंकि ये जो भी चीजें मैंने स्लाइड पे लिखी हुई है ये आपको टेलीग्राम ग्रुप में मिल जाएंगी. दैट इज शेफाली मैम टेस्ट बुक. So on the daily basis, I'm sharing the PDF of all the YouTube sessions. You can ask your doubts in this group. Discussion and doubt solving is there. You can directly interact with me. Also, the quiz and polls will also be posted in this group. You can give the response and you can see कि आपकी preparation कैसी चल रही है. You can search for Shefali ma'am textbook or straight away directly go to the description of the video. In the description, I guess that's the third link. So just click on that and it will take you to the Telegram group. Okay. So here is the best case and the worst case for. I just talk about here on the slide. I talked about merge function only. How merging is done for two lists. Okay, so this was with DAC. अभी जो हमने discuss किया that was the solution with DAC. Without DAC में क्या होगा? What will be happening in without DAC? Without DAC means will not be dividing the elements into the sub problems, right? Will not be dividing the problem into the sub problems. So without DAC means, for example, you are given with the elements like 11, 21, 10, 20, 1, 2, 15, something like this. So this is an unsorted array. Now we have to sort these elements using the merge sort, but without DAC. So what we'll be doing is, we'll be considering each element as an individual element. Okay, so at a time we will be, this is just the reverse of what we did in the divide and conquer. Divide and conquer में पहले हमने divide किया था and ultimately divide करते करते हम single element पे पहुंच गए थे. Now already we'll be considering the single element and will merge it. So output will be 11 and 21. This in the sorted order it will be 11 and 21. Merge them, output will be 10 and 20. Merge the next two elements, output will be 1 and 2. Take the next element. There is only one element, so this will be coming as it is. So without DAC, one time the question was asked, so without DAC, you were supposed to return the output in pass 2. So this is the output in pass 1. After applying pass 1, without DAC, output will be 11, 21, 10, 20, 1, 2, and 15. In pass 2, again we'll be merging two nodes from a tree. We are merging two lists. 10 will be compared with 11, or 11 will be compared with 10, so 10 is smaller. Next, 11 will be compared with 20, 11 is smaller. 20 will be compared with 21, 20 is smaller. Then we are getting 21 here. So we got one list here. Merge them. 1 will be compared with 15, 1 is smaller. 2 will be compared with 15, 2 is smaller. We are left with one element. This is the output after pass 2. Again, कब तक करेंगे? जब तक आपके पास एक लिस्ट नहीं मिल जाती. So we'll combine this, we'll merge it, and here we'll get 1 will be compared with 10, so we'll be getting 1, 2 will be compared with 10, 2, 10, 15, 10, 11, 15, 20, and 21. So this is how without divide and conquer approach works. This is the output after pass 3. So finally, after 3 passes, elements get sorted. So basically, what should be the time complexity, or how many levels or how many passes are required? First of all, let's talk about the number of passes required here to get the result. Number of passes. If you look at this tree from the reverse order, there is only one node. End पे आपको एक ही list मिलेगी, and then we have 2 lists, 4 lists, and like that. So basically, it's like complete binary tree, and we know that in a complete binary tree, log n levels are there. Levels here are working as the passes for the algorithm. और base क्या रहेगा? अगर आपके पास two-way merging है, two-way means at a time we are combining 2 nodes, so it will be log base 2n. If it is three-way merging, at a time we are considering the 3 nodes of a tree, then it will be log 3. So it will be log base m if it is m-way merging. And n is representing here the number of elements. Okay, so this is with this we have discussed the solution with two-way merging. Is this clear? So this is all about merge sort. We have covered the case of merge sort with DAC and the without DAC. Let me ask few questions from you guys. If I want to find out if we are given with two lists, list 1 is of size m, list 2 is of size n, list 2 is of size n, then in the worst case, what will be the number of comparisons required to merge list 1 and list 2? List 1 is of size m, is of size m. I want to find out the number of comparisons required for merging these two lists. So obviously here we'll be having two cases. One will be the worst case, best case and the worst case. Best case में कितने comparisons चाहिए होंगे and worst case में कितने comparisons चाहिए होंगे. Here I have written the answer, so from there you can take the help. Moreover, help लेने की जरूरत वैसे होनी नहीं चाहिए because I have explained the concept by taking examples for both the cases. So if in one list m elements are there, in second list n elements are there, so total number of elements, total elements will be elements of list 1 plus elements of list 2, right? In the best case, it's taking half of the total number of elements. Total number of elements are m plus n. So here it will be returning m plus n divided by 2. Yes? And in the worst case, it's taking the number of comparison equal to total number of elements, total elements minus 1. So in our scenario, total number of elements are m plus n and minus 1. So this is going to represent return the number of comparisons and the best case or the worst case. अभी शायद आप लोगों को समझ में नहीं आ रहा है, but when we'll be talking about the questions, when we'll be solving the questions, you'll get to know that it's a very important point to return the number of comparisons in the worst case. Okay. All right. So this is all about merge sort. Now, next application that we are going to cover is to find the minimum and the maximum elements in the given array. So I guess pretty straightforward problem. एप्लीकेशन देख के समझ में आ रहा है. We want to find out the minimum and the maximum element in the given array. That means you will be given with an array and you have to find out the minimum and the maximum element. Let's consider an array. First of all, we'll consider the case that is without DAC. I'm taking an array, unsorted array, 10, 20, 30, 1, 2, 3, 11, 21, and 31. Let's assume that this is the case. And here we have the index of the arrays. I'm considering this as 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now, according to the problem statement, expected output is, this is the input, some unsorted array will be behaving as the input. Some array of elements is given as, it may or may not be the sorted or unsorted. So kuch array aapko given hai as the input, and expected output is what will be the minimum element in the array. What is your normal approach? We'll start from the first element और फटाफट से इसको scan करेंगे. As of now 10 is smaller than 1 and that's it. 1 से smaller कोई नहीं आया. Similarly, for the maximum element, we'll say that as of now, initially 10 is the maximum element. यहाँ पे हमने क्या किया? 10 was considered first element को हमने minimum element consider किया. Then we are looking at the next element. 20 is smaller than 10? No. 30 is smaller than 10? No. 1 is smaller than 10? So it's updated. First element को ही हमने minimum और maximum consider कर लिया. So minimum 20, 30. Now take the next element. 1 is smaller than minimum, so minimum update हो गया. 2 is smaller than minimum? No. 2 is greater than maximum? No. It won't update the value. 3 is smaller than minimum element? No. 3 is greater than maximum element? No. Take the next element. 11 is smaller than minimum? Greater than maximum? No. 21 is smaller than minimum? Maximum say greater है? No. Take the next element. 31. 31 is smaller than minimum element? No. 31 is greater than maximum element? Yes. 31 is greater than 30. So finally, it is returning the answer. This is without DAC. So expected output क्या थी आपके पास? Minimum element is 1 and maximum element is 31. So we are getting the minimum and the maximum element. So the idea behind this is हम एक simple scan कर रहे हैं and for each element we are doing two comparisons. एक comparison कर रहे हैं to compare it with the minimum element कि जो आपने element select किया है, is it smaller than the minimum element? If not, then we are going for the comparison with the maximum element. The element selected is greater than maximum element or not. If yes, अगर दोनों में से कोई भी condition satisfy करता है minimum और maximum की, then we'll update the value. So in this case, can you tell me that what should be the time complexity? Straight, let me call this function as straight min max. Here we were given array as the, let me see if algorithm is written. Yeah, it's already written for your reference. So what we are doing here is we are taking the array as the input. This is the array. In array, n elements are there, number of elements, and we are supposed to return the minimum and the maximum element. So I'm considering an integer variable I, max and min is equal to a of 1. That means the first element is considered as the minimum element. First element is the minimum element and maximum element. Initially min and max is the first element. After that, from second element onwards, we are going to do the comparison. Second element से लेकर कहाँ तक जाना है? Till the nth element. Every time we are going to consider the next element. At index 2, whatever element is there, at index 2, जब आपने A of I किया तो it is returning the element. We are looking that at index 2, whatever element is present, is it greater than maximum element? If this condition is true, then max will be updated. Otherwise, we'll check. अगर मैक्स अपडेट नहीं हुआ तो हो सकता है कि एलिमेंट स्मॉलर हो, बट डायरेक्टली हम एल्स के बाद मिन को अपडेट नहीं करवा सकते, बिकॉज आपके पास कुछ एलिमेंट्स बीच में ऐसे भी आएंगे जो ना मिनिमम होंगे ना मैक्सिमम होंगे. सो फॉर मिनिमम ऑल्सो वी नीड टू प्रोवाइड द कंडीशन इफ ए ऑफ आई इज लेस देन min, that means जो selected element है that is smaller than min, then min will get updated. Once second element comparison is done, then we'll be considering the next element, update the value of I. If it is less than equal to n, सारे elements explore नहीं हुए, then again we'll be repeating the same process. So this is how the for loop will work and it will reach to the end. जब end पे पहुंच गए तो obviously max variable and min variable will be returning the minimum and maximum element from the array. Can you tell me that without divide and conquer, what will be the time complexity? Here simply you are supposed to do the analysis, right? So first statement will be executed for one time क्योंकि declaration और integer variable के it's not under the control of any loop. So obviously this is going to execute for one time only. After that, we are initializing the values to the min and the max. So this will also be executed for one time. If you look at this for loop कहाँ से कहाँ तक जा रही है? I की value 2 से शुरू होकर 2, 3, 4 and so on. This is going till n. So basically, how many times this loop will be executing? 2 से शुरू होकर n तक जा रहे हैं. So it is executing for n minus 1 times. और उसके बाद we are just returning the value of the variable maximum and min. This will also take constant time. First step is taking constant time, second is taking constant time, third is taking n minus 1 times, and fourth will be executed for one time. So this means that this step is taking the maximum time. So the time complexity here is its order of n. Best case है तो भी क्योंकि लूप में कहीं पे आइडेंटिफाई नहीं कर रहे बेस्ट केस है या वर्स्ट केस है, सो बेस्ट केस में भी दिस इज n एंड वर्स्ट केस में भी दिस इज n. So simply we can say that it is taking theta of n. This is the time complexity for finding the minimum and the maximum element in the given array without divide and conquer. क्योंकि यहाँ पे हमने प्रॉब्लम को डिवाइड नहीं किया. Here is the solution. So we are just performing, it's just like the linear search one after the another. Make sense? Anyone having any doubt in finding the minimum or maximum element? वैसे इसमें तो बिल्कुल doubt आना ही नहीं चाहिए. I guess this is the straightforward approach जिसको हम brute force method बोलते हैं. अगर हमने कोई भी algorithm study नहीं किए, then also we'll be following this approach only, right? Anyways, next one is finding the minimum element and the maximum element in the given array. Let's understand this with the help of the example because बाद में आपके पास ये code आ जाएगा. So I don't want you guys to get scared. Alright, so let's consider an array. Thank you Kanjan for the confirmation. यहाँ पे हमने एक array लिया, unsorted array. And in this I want to find out the minimum element and the maximum element. 10, 20, 11, 21, 30 and 1, 2 and let me take this as 8. Take any number of elements. Already this is unsorted. 15 and 18. Let's say this is an array. So what is the expected output? Simply we have to return the minimum and the maximum element. What will be the expected output? Maximum element is 30 here in this array and the minimum element is 1. Index 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Idea behind this is divide and conquer means this is with DAC. So idea behind this is we'll be dividing the problem into the sub problems. दोनों अब जो minimum element या maximum element हमें find करना है, it can either be present on the left hand side or on the right hand side. इसको हम फिक्स नहीं कर सकते कि हमेशा मैक्सिमम एलिमेंट लेफ्ट साइड पे होगा या राइट साइड पे होगा. वी कैन नॉट डू दैट. सो बेसिकली वी हैव टू फाइंड आउट द मैक्सिमम एलिमेंट एंड मिनिमम एलिमेंट ऑन बोथ द साइड्स. टर्मिनेशन कंडीशन विल बी अगर आपके पास एक ही एलिमेंट है दैट विल बी रिटर्न्ड एज इट इज. सो मिनिमम एलिमेंट विल बी दैट एंड मैक्सिमम एलिमेंट विल बी दैट. What I'm saying is because we have to write the termination conditions also because यहाँ पे हम DAC की बात कर रहे हैं. So if I is equal to j, that means there is only one element. अगर एक ही एलिमेंट है तो मिनिमम भी वही होगा. min will be equal to max equal to a of I. As simple as that. If we have two elements like 11 and 5, this is index 1, this is index 2, or let me call this as I and this as j, index I and j. So if j is equal to or I is equal to j minus 1, कंडीशन आप कैसे भी दे सकते हो. j is equal to I plus 1 और I is equal to j plus I is equal to j minus 1. What does it mean? जो फर्स्ट एलिमेंट है उसका इंडेक्स लास्ट एलिमेंट के इंडेक्स से एक कम है. दिस कंडीशन इंडिकेट्स दैट वी हैव टू एलिमेंट्स इन एन एरे. So just one comparison will be required. दो ही एलिमेंट्स है, so we'll be comparing this as if a of I is less than a of j. If this is the scenario, then simply we can say that max will be equal to a of j and min will be equal to a of I. One comparison is required. So these two will be working as, if this is the case, then max will be this and min will be this. Otherwise, else, अगर ये condition true नहीं है, else means a of I is greater than a of j, then we'll be saying that max is equal to a of I and min is equal to, ये सिर्फ अंडरस्टैंडिंग के लिए, प्रॉपरली इट्स रिटन ऑन द नेक्स्ट स्लाइड, a of j. So let's go through it. पूरे कोड को देखकर एकदम से डरना नहीं है. मोस्टली स्टूडेंट्स क्या होते हैं, बहुत लेंथी कोड है, ये प्रॉब्लम कॉम्प्लेक्स होगी. So if you observe here, we are taking an array, starting index, last index, and we are supposed to return the minimum element and the maximum element. This is the array name. This is the starting index of an array. Starting index of an array. Ending index of an array, and we are supposed to return the minimum or the maximum element. Since we have to divide the problem into the smaller parts, so we are declaring one integer variable mid, but अभी तक इसकी जरूरत नहीं आई है. So first case में we are saying if I is equal to j, that means this is the case when there is only one element. When there is only one element in the array. If there is only one element, so without any comparison, we can say that maximum and minimum element will be same and it will be pointing to that particular element and we can return the maximum or the minimum element. If I is equal to j minus 1, this means that we have two elements in the array. यही केस हमने डिस्कस किया. अगर दो एलिमेंट्स है, one comparison is required. If a of I is greater than a of j, so maximum will be a of I and minimum will be a of j. If this condition is true, if a of I is less than a of j, so it is going to the else part. So maximum will be a of j and min is equal to a of I. Half code over. So this is about the when the problem is small. If the problem is large, what we'll be doing is we'll be dividing this problem. हमने termination conditions determine कर ली, so we are getting here two termination conditions for one element and for two elements. Now we'll be dividing this problem on the basis of the mid. We need to find out the minimum and the maximum element in the first half of the problem, in the second half of the problem. Since it's not matching with any of the termination conditions, so again we'll find out the mid. 1 plus 5 is 6 divided by 2 is 3. So first part में आपके पास 3 elements आ गए. 1, 2, 3. Again, this is not the smaller one. So what I'm saying is, here we have the elements 1, 2, 3. और यहाँ पे आपके पास elements है 4, 5. It's very similar to what we have done in the merge sort. Let me draw it properly. So in the first part, we are getting the elements from 1 to mid. That is 1 to 5. Problem is not small. And in this case, we are getting the elements from 6 to 10. Basically, this is the starting index I. And this is what we have obtained from mid. And here we are getting first index is mid plus 1. And this is J. So we have to make a same call on both the parts of the problem. This is not a small problem. So again, we'll be dividing this further. 1 plus 5 is 6. So mid will be 3. 1 to 3 and 4 to 5. Here we'll be getting 6 to 8 and 9 to 10. 9 to 10 means 2 elements are there, so we need not to expand it further, but definitely we need to divide this. Here we'll be having 2 elements and here we'll be having only 1 element. In this case also, we'll be having 2 elements in the first part and in the second part we are having 1 element. अब जो आपके पास nodes हैं, it is either containing the single element or 2 elements and we have defined the condition for the both. First 2 elements are 10 and 20. So we'll do the comparison on starting and the ending index. So on the basis of this, we can determine we are getting the minimum element as 10 is less than 20. So minimum will be 10 and maximum will be 20. Here only 1 element is there. So minimum and maximum will be that element itself. Minimum is index 3 pe element is 11. Maximum is 11. Right? अब क्या होगा? We need to return the solution for this problem. We have got the solution for the sub problems. Now we need to get the solution for this problem. If you observe here, we are getting 2 minimum values. So we'll be comparing these 2 minimum values और इनमें से जो smaller होगी that will be returned here. Minimum will be 10 or 11. It's 10. Maximum will be 20 or 11. We are getting 2 maximum values. So we'll merge it. Maximum is 20. For 4 and 5, we are doing the comparison. Here we are getting the maximum value. Though elements are maximum is 30 and minimum is 21. Now again we are available with 2 minimum values. 10 and 20 will be compared and we'll get the solution here. Minimum will be 10 is compared with 21. Minimum is 10 and maximum is, both the maximum values are compared. Maximum is 30. That means out of first 5 elements, we have got the solution for the sub-problem. Out of first 5 elements, 10 is the smallest one and 30 is the largest one. Same process will be applying on the right hand side, 6 and 7. Here we'll be getting the minimum value. Minimum is 1, maximum is 2. 8, minimum will be 8, maximum will be 8. Now we are having 2 minimum and 2 maximum values. So in order to get the final solution, we'll be comparing both the minimum values. So finally minimum will be 1 here and maximum is 8. 9 and 10, minimum is, are you getting what I'm doing? Maximum is, हम क्या कर रहे हैं? Smaller problems में we are finding the minimum and the maximum element, and then in order to get the solution of the original problem, we are comparing 2 minimum values which we have obtained from the sub problems to get the final minimum value. अब दोनों minimum values को compare करेंगे 1 and 15. This is returning that minimum is 1 and maximum is, compare both the maximum values 8 and 18, so it's 18. Now by this time we have the minimum value as 10 and minimum value as 1. So when we'll merge this, we'll get min is equal to 1. Compare both the maximum values 30 and 18. We are getting the maximum value as 18. Maximum value is 30 is greater, so 30 is the maximum value. So this is how divide and conquer approach works. ये concept समझ में आया? So now let's look at the code. First of all, what we did is, this is the very first step of the divide and conquer, to divide the large problem into the sub problem. So this is divided into two parts on the basis of the mid. Since we have to find out the minimum or the maximum element, ये first half में भी हो सकते हैं, second में भी हो सकते हैं, so we cannot ignore any part of the problem. So we'll be making a call on left side as well as right side. Left side पे index के, this is from I to mid. If this is the mid, तो कहाँ तक जा रहे हैं? I से लेकर mid तक. And second problem में we are starting from mid plus 1 to J. So let's look at the parameters here. I से लेकर mid तक array name is same. We are supposed to find the maximum and the minimum element, so there is no change. But अगर आपके पास recursive call है, number of parameters same रखने पड़ेंगे, but at least one of the parameter value should change. So here, second parameter value, the last index is changing here. So this is the first part. We are making the similar call on the second part. If total n elements were there in the original problem, we are dividing the problem on the basis of the mid. So it will be containing n by 2 elements, and we are making the same function call. On the second part also, we are making the same function call. By the end of these two function calls will be available with two maximum values and two minimum values. Let me call this as max1 and min1, max2 and min2. आपके पास दो minimum values हैं, दो maximum values हैं. So in order to get the final minimum value or maximum value, we need to do the comparison on both. So if maximum1 is smaller than max2, so obviously final maximum will be max2. Otherwise, if this condition doesn't hold, so max will be equal to max1. So we have done the comparison on both the maximum values. Similarly, we'll be doing that on the minimum values to get the final minimum value. If min1 is less than min2, then it will be returning min1 and so on. मैम इससे डायरेक्ट क्वेश्चन आएगा या एल्गोरिथम भी आएगा? एल्गोरिथम यूजुअली नहीं पूछे जाते, आपसे रेफरेंस रिलेशन पूछा जा सकता है, टाइम कॉम्प्लेक्सिटी पूछी जा सकती है, और नंबर ऑफ कंपैरिजंस पे क्वेश्चंस पूछे जा सकते हैं. Okay, so can you tell me that what will be the recurrence relation here? We have already got the termination conditions. We have determined the termination conditions. एल्गोरिथम कोई नहीं पूछेगा, बट इफ यू हैव अ गुड अंडरस्टैंडिंग ऑफ द एल्गोरिथम की, जैसे मैंने एग्जांपल लेके आपको बताया हाउ दिस इज वर्किंग, देन इजीली यू कैन राइट द एल्गोरिथम. तो ये आपके सेमेस्टर एग्जाम्स में हेल्पफुल होगा, बट इस तरीके के एल्गोरिथम्स गेट एग्जाम में नहीं आते हैं. नाउ क्वेश्चन विल बी लाइक कि मैम फिर आप क्यों करवा रहे हो? बिकॉज आई वांट यू टू अंडरस्टैंड हाउ वी गेट द रेफरेंस रिलेशंस. रेफरेंस रिलेशंस कहीं बाहर से नहीं आते, जो आप स्टेप्स फॉलो कर रहे हो उन्हीं को हम मैथमेटिकल फॉर्म में लिखते हैं. दैट इज अ रेफरेंस रिलेशन. सो आई वांट टू राइट द रेफरेंस रिलेशन हियर. If there is only one element, if n is equal to 1, then how many comparisons are required? No comparison is required. बिना किसी comparison के हमने minimum और maximum element return कर दिया. If n is equal to 2, अगर आपके पास दो elements हैं, then in this case one comparison is taking place. आपने ये if condition एक ही बार check किया, उसके बाद आपने values assign कर दी, so one comparison is taking place. If n is greater than 2, that means the problem is large. अगर problem large है, then we are going to the else part. Problem is large, we are going to the else part. So in the else part, first of all, we are taking the constant time to find the mid of the problem, constant time. After that, we are making the same function call. पहले हमने n elements पे apply की थी. Now in first part, we have n by 2 elements. It is n by 2 elements. After that, n by 2 elements. This is to divide the problem. Now in order to return the solution, final solution return करने के लिए, merge करने के लिए, we are making one comparison here and one comparison here. So in addition to this, two more comparisons are taking place. इतना ही टाइम लग रहा है, इसके अलावा और कोई टाइम, नथिंग इज रिक्वायर्ड. So let's simplify this. जो time complexity return करेंगे, that will be returned on the basis of the recursive statement only. So this comes out to be t of n. Constant is not going to play. This is constant value. This is constant value. तो simply हम ये बोल सकते हैं additional time required to divide the problem or to return the solution is some constant time. Tn by 2 plus Tn by 2. I can write this as 2Tn by 2 plus additional time हमें कितना चाहिए? That is some constant time. Now, can you tell me that what will be the time complexity here? Because here we can return the, we can use the Master's theorem, basic Master's theorem. A or B की value same है, n raised to power log A or B, that comes out to be 1. So it comes out to be n, and obviously linear time is greater than constant time. So here we are getting the time complexity as theta of n. With DAC, we are getting linear time complexity, और without DAC भी यही हुआ था. We had used one for loop, यहाँ पे एक for loop use की थी, and without DAC time complexity was same. So in this particular case, we are getting the same time complexity with DAC and without DAC. So which method will you be using? Which method will be used? Which approach? Not the method, which approach will be followed in order to find out the maximum or the minimum element? With DAC or without DAC? Usually हम ये बोलते हैं कि with DAC हमारे पास time complexity, time required is less, so we prefer divide and conquer. अगर without divide and conquer कम time चाहिए तो हम without divide and conquer follow करते हैं. अब यहाँ पे same time complexity. So with DAC and without DAC, it is taking same time complexity. So which approach will be followed and why? Yes. So in this case, so without DAC will be preferred. Why? Without DAC will be preferred. Why? Without DAC क्यों prefer करेंगे? Answer is right. Without DAC prefer करेंगे, but क्यों? Okay. This is because जब हम DAC की बात कर रहे हैं, इसका मतलब recursion involved है, and in order to solve the recursive problem or the recursive statement, some extra space is required. We know that whenever we are doing the comparison of two algorithms, first of all, we are doing it on the basis of the time complexity. अगर कोई दो algorithms की time complexity same है, then in that case, we have to follow this, we have to consider the space complexity. So in this example, we are getting the same time complexity, so we need to consider the space complexity, and for solving the recursive program, some extra space is required in the form of the stack space is required. We know that recursion is an application of stack, so that's why extra space is required with DAC. So that's why without DAC is preferred. Make sense? टाइम डिक्रीज होता है, टाइम तो हमने बोला कि सेम है, टाइम सेम है तो डिक्रीज कैसे होगा? टाइम इज ऑर्डर ऑफ एन ओनली. I hope that this is clear to everyone. So we'll end our discussion here. Tomorrow I'll be talking about quicksort algorithm. Very very important. You can say कि अगर इस यूनिट से डिवाइड एंड कॉन्कर से क्वेश्चन आ रहे हैं तो if अभी तक 50 क्वेश्चंस आए हैं तो 40 क्वेश्चंस और सो 35 to 40 questions will be from quicksort, directly or indirectly कहीं ना कहीं quicksort आएगा ही आएगा. So we'll discuss about quicksort in detail. It's very very important application of divide and conquer. Apart from that, since quicksort is a sorting technique, तो मैं कल 3 properties भी discuss करूंगी. कैसे आप find out कर सकते हो कि जो sorting technique है that is adaptive or not. वैसे थोड़ा सा overview दिया आज मैंने आपको. In place है या नहीं है, यानी कि elements को sort करने के लिए extra space is required. then it's not the in-place sorting technique. And if extra space is not required, it is utilizing that space only. So it's the sorting, it's the in-place sorting technique. And we'll also talk about the stability. Okay. In another 5 minutes, guys, this PDF will be available in the group that is Shefali ma'am Testbook. So अगर आपने अभी तक ज्वाइन नहीं किया तो आप इस ग्रुप को ज्वाइन कर सकते हो ताकि आपको अपकमिंग सेशंस के लिंक्स भी मिलते रहे एंड यू ऑल्सो गेट द PDF ऑफ ऑल द यूट्यूब सेशंस. तो जब सारी PDF मिल रही है विद लिंक मिल रही है तो आप सेशन में सिर्फ और सिर्फ कॉन्सेप्ट अंडरस्टैंडिंग पे फोकस कर सकते हो. उसके अलावा अगर आपके कोई भी डाउट्स है आप ग्रुप में पोस्ट करो, यू विल गेट द रिस्पॉन्स. ऑल्सो अगर बाकी लोगों ने ग्रुप पे कुछ डाउट्स पोस्ट किए हुए हैं तो आपको देख के समझ में आ जाएगा कि वो डाउट आपका भी हो सकता है आपके माइंड में वो डाउट ना आया हो, और अदर केस माइट बी आपको वो कॉन्सेप्ट क्लैरिटी है, सो यू कैन पार्टिसिपेट इन द डिस्कशन, यू कैन क्लियर द डाउट्स ऑफ अदर स्टूडेंट्स एज वेल. तो इससे आपको भी कॉन्सेप्ट में और क्लैरिटी मिलेगी. Apart from this, if you want to interact with me, you can directly interact with me. कुछ quiz और polls के questions होंगे, आप उसमें participate कर सकते हो. इससे आपका एक track बना रहेगा क्योंकि randomly किसी भी topic से question आएगा तो आपको समझ में आ जाएगा कि question करने से पहले आपको revision की जरूरत अगर पड़ रही है, that means still there is a scope of improvement. Otherwise, you are good to go. Let me share my screen with you guys where you can find the link of this YouTube session. एक बार मुझे confirmation दे देना if my screen is visible. Hope my screen is visible. So I'm going to the description of this video. In the description, you can see here we have GATE CSE 2024 100% Achiever Masterclass series. In this masterclass, I'm covering the previous year questions from the topics. जो topic हम YouTube पे cover कर रहे हैं आपने देखा होगा. मैं सिर्फ examples ले रही हूँ. I'm just taking the practice questions if required, but I'm not solving the previous year questions in the YouTube sessions. So previous year questions or practice questions हम masterclass में solve कर रहे हैं, so you can join it. And you can, if you are targeting on NIC, so you can follow the second link. This is the link for the NIC Super Coaching. Okay, here is the third link. This is for GATE Super Coaching Telegram group. So आप इस link को follow करके Telegram group join कर सकते हो. And if you want to cover 100% syllabus like this, then you can join the Super Coaching batch. Just click on this link and it will take you to the Testbook platform. Major benefits of the Super Coaching are आपको एक से ज्यादा एजुकेटर से कॉन्सेप्ट पढ़ने का मौका मिलेगा. एक से ज्यादा का मतलब ये नहीं है कि डिफरेंट सब्जेक्ट्स आर टॉट बाय द डिफरेंट फैकल्टीज. वन सब्जेक्ट is covered by many educators. For this, let's go to the plan here. There is a complete course by GATE Forum, तो obviously हर एक subject इसमें cover हुए. Then there is the complete course by Digimento, so each and every subject is covered in by Digimento as well. Then we have Nimbus Learning. Each and every subject will be covered in Nimbus Learning, and you can see here is the folder which is provided, which is created by me and my team. So a complete preparation is there. 250 प्लस वीडियोस हैं इंग्लिश लैंग्वेज में, इसमें भी आप हर सब्जेक्ट कवर कर सकते हो. सो दिस वे देयर आर मल्टीपल सेशंस अवेलेबल ऑन ईच टॉपिक, सो इट्स अप टू यू व्हिच वन यू वांट टू फॉलो. बट ये जो सारे सेशंस होंगे दीज विल बी इन द रिकॉर्डेड फॉर्मेट. एंड in the live series there is a tab for the live series. Live series will be on the quick revision. आप डिटेल में concepts learn कर लो, उसके बाद फटाफट से quick revision में we will be covering all these concepts in the live sessions, and there will be the separate sessions for the doubt solving, completely dedicated for doubt solving, practice and previous year questions, और mock test के जो भी questions होंगे that will also be discussed here. So mock test is provided, study notes will also be provided. ये जो study notes होंगे these will be available in the PDF format. Engineering mathematics, general aptitude, formula notes means short notes जो एग्जाम से पहले बेनिफिशियल होते हैं, क्योंकि एग्जाम के टाइम पे आप अगर 10 सब्जेक्ट से 10 के 10 सब्जेक्ट की नोटबुक्स उठा के आप रिवीजन नहीं कर सकते. सो फॉर्मूला नोट इज लाइक एक पेज पे आपके सारे इंपॉर्टेंट पॉइंट्स आगे रिलेटेड टू वन सब्जेक्ट. सो इफ वी हैव 10 सब्जेक्ट्स, so in total there will be 10 pages. So in order to quickly go through the 10 pages, it will hardly take 15 minutes, right? तो इस तरीके से आप फटाफट से go through कर सकते हो सारे concepts को. And कंप्यूटर साइंस इंजीनियरिंग में जितने भी टेक्निकल सब्जेक्ट है सबकी पीडीएफ नोट्स अवेलेबल है. तो आप यहाँ पे अगर सब्जेक्ट्स देखोगे, ये सारे के सारे सब्जेक्ट सेकंड और थर्ड ईयर बीटेक में पढ़ाए जाते हैं. Correct? So if you are in the second year or third year, you can also join this batch. Here is the pricing. So there are three plans: 36-month plan, 24 months, 2-year plan and 1-year plan. 1-year plan is basically recommended. वैसे एक साल का plan sufficient होता है for the GATE preparation, provided आप dedicatedly prepare कर रहे हो. अगर आपको लगता है कि कॉलेज का भी थोड़ा सा लोड है, then in that case I'll suggest you to go for 2 or 3-year plan. 2-year plan will be okay for second year or third year students, but अगर आप first year से preparation start करना चाहते हो, then in that case you can go for 3-year plan. So coupon code is given in the description. Coupon code is Shefali S. तो ये जो प्राइजेस आपको दिख रहे हैं, these are after applying the coupon code. आप देख रहे हो कि ये कट करके ओरिजिनल प्राइस को कट करके this is the discounted price. So if you will be applying the coupon code Shefali S, then you will be getting the course at this price. Okay. So this is all about the super coaching. Difference between a super coaching masterclass. Masterclasses are free, but not 100% syllabus will be covered in that. So if you want to completely cover the syllabus in depth, then in that case go for super coaching. All right. So in the next session tomorrow, we will be talking about the quick sort and the properties of the sorting techniques. And now let me talk about the schedule of the upcoming classes. Guys, Monday to Friday, I'm taking 2 sessions. हर सेशन में मैं आपके साथ ये schedule डिस्कस करती हूँ just to show you that same schedule we are following for all the weeks. And if there will be any change या फिर due to some emergency, if I had to take a leave, that will be posted in the Telegram group. Okay, तो जो भी information होगी, everything will be shared with you guys in the Telegram group. So 4 p.m. पे we have the YouTube session, whereas at 8 p.m. we have the masterclass. As already discussed in the YouTube, we are covering the concepts, and in the masterclass we are covering the questions. Saturday and Sunday will be having the sessions on GATE, ISRO at 6 p.m. at 9 p.m. Both the sessions will be on YouTube. 1 hour sessions रहेंगे. तो जो लोग ISRO के लिए prepare करें, they can revise the concepts because I'm covering these concepts on weekends. Saturday and Sunday दोनों दिन यही structure रहेगा. जिन लोगों ने अभी तक ISRO का फॉर्म नहीं फिल किया, बेटा ISRO का फॉर्म फिल कर दो. डेडलाइन इज 14th of June. इट्स अप्रोचिंग. लास्ट मोमेंट तक वेट मत करो, क्योंकि लास्ट मोमेंट पे कई बार आपको टाइम नहीं मिलता, या माइंड से स्किप हो गया, या पेमेंट इशू हो गया, वेबसाइट डाउन हो गई, देन इट विल बी अ प्रॉब्लम फॉर यू. क्योंकि इसरो की वैकेंसीज 3 साल के बाद आई है. लास्ट टाइम जो इसरो का पेपर हुआ था दैट वाज इन जनवरी 2020. अभी आप देख लो कि इट्स जून 2023. सो इवन इट्स मोर देन 3 years. ओके, सो डेडलाइन इज 14th of June. अगर आप एलिजिबल हो तो डेफिनेटली मैं आपको रेकमेंड करूंगी कि आप इस फॉर्म को फिल करो. सिलेबस बिल्कुल गेट सिलेबस जैसा ही है, सिर्फ 1-2 सब्जेक्ट्स एक्स्ट्रा लाइक वेब टेक्नोलॉजीज, बट उसमें से बहुत ज्यादा क्वेश्चंस नहीं आते. इनफैक्ट जो ये सेशंस चल रहे हैं, अगर आप इसरो की प्रिपरेशन कर रहे हो तो आप गेट वाले सेशंस को ज्वाइन कर सकते हो. जो गेट एस्पिरेंट्स है दे कैन ज्वाइन द सेशंस ऑन इसरो, क्योंकि इसरो वाले में मैं पीवाईक्यूज ले रही हूँ, तो आपको पता चलेगा कि जो टॉपिक्स आप ऑलरेडी कवर कर चुके हो उनसे और किस टाइप के क्वेश्चंस पूछे जा सकते हैं. ओके, सो दिस इज द बेनिफिट. एंड सैटरडे संडे होता है तो जो भी आपका ऑफिस है, कॉलेज है, दैट लोड विल नॉट बी देयर, सो इजीली यू कैन ज्वाइन दिस सेशंस. मोर ओवर द ड्यूरेशन इज जस्ट एन आवर, सो इजीली यू कैन टेक आउट द टाइम. सो डेली मैं आपके साथ टाइम क्यों शेयर करती हूँ, ताकि आप अपना स्केड्यूल, अपना स्ट्रक्चर उस तरीके से बनाओ ताकि आप लाइव सेशंस ज्वाइन कर पाओ। बेनिफिट होता है लाइव सेशंस में, यू कैन डायरेक्टली इंटरेक्ट, यू कैन आस्क योर डाउट्स। रिकॉर्डेड सेशंस देख रहे हो, डाउट्स आएंगे, फिर आप किसी ग्रुप में पोस्ट करोगे या फिर चैट सेक्शन में लिखोगे, और फिर कब वो आपका डाउट पिक होता है तो आपके डाउट्स बहुत बार पेंडिंग रह जाते हैं। सो डोंट डू दैट, ट्राई टू ऑलवेज ज्वाइन द लाइव सेशंस। So guys, this is all from my side. If you guys have any doubt or any query, please let me know. Otherwise, we'll end our discussion here and I'll see you at 8 p.m. Any doubt or query? Very good evening, Prashant. आज काफी जल्दी सेशन ज्वाइन नहीं कर लिया? Any doubt guys? जो मैं टाइम शेयर करती हूँ उसके अकॉर्डिंग 5 p.m. एंडिंग टाइम है, नॉट द स्टार्टिंग टाइम ऑफ द सेशन। Missed the class? Yeah, I know that. Anyhow, I'll share the PDF in the Telegram group. Just go through it and you can watch the recorded session as per your convenience. जिन लोगों ने लाइव सेशन ज्वाइन किया था, एनी डाउट? वैसे अभी तक नहीं आया तो इट वॉन्ट बी देयर। 8 p.m. में कौन सा क्लास है मैम? इट्स द मास्टर क्लास। आज वाले सेशन में हम लोग प्रीवियस ईयर क्वेश्चंस करेंगे फ्रॉम द फर्स्ट टॉपिक ऑफ द एल्गोरिथम्स, दैट इज एनालिसिस ऑफ एन एल्गोरिथम। पहला टॉपिक जो हमने एल्गोरिथम का डिस्कस किया था दैट वाज एनालिसिस। जिस सीरीज में यूट्यूब सेशंस आए उसी सीरीज में मास्टर क्लास जाएगी। आज का टॉपिक है PYQs ऑन एल्गोरिथम एनालिसिस। टाइम में कोई चेंज नहीं है? एनी अदर डाउट? I guess it's not there. So let's end our session here. I'll see you at 8 p.m. Till then, take care. Bye bye. God bless you.